Okay, now we're starting chapter 6 about factoring. This is a very, very important chapter because you'll use it for the rest of the semester. You've got to know how to factor. So some definitions right at the very beginning. Factors are numbers that we can multiply together to get another number. So 1 and 8 are factors of 8, as are 2 and 4. There's different ways that I can get 8, but that's all factors are. Something that we can multiply together to get something else. Now the greatest common factor, we also call this GCF, short. That is an expression of the highest degree that will divide each term of a polynomial. So let me go on down just a little bit. The variable part referring to the x's here, always contains the smallest power of that variable that appears in all terms of the polynomial. So if I was looking first at the coefficients, I've got to find the largest number that will go into both of these. I know 8 has these factors. I know 28 has these factors. But the highest number that they have in common is 4. So 4 would be my coefficient that I could factor out. But with respect to the variable, it's the smallest. So what these two would have in common, my GCF, would be 4x. Alright, now, in the next 3 problems, they want us to find the greatest common factor of each list of monomials. So I'm going to do the first one, then I'm going to let you do the other 2 because I need you to pause me. 6 and 10, the smallest coefficient would be 2. That would go into these evenly. With respect to the variables, it would be x squared. You'll have more trouble finding the largest number that will go in through the numbers because the variables, well, you just have to look for the smallest exponent. Now this one I've got y's. So again, pause me. See 15, -9, and 27. The largest number that will go into all 3 of those would be a 3. As with respect to the variables, it would be y cubed. This one, my coefficient is 1, so I don't worry if it's 1. But x, I would be factoring out a 3. My y's, it would be y squared. So that would be my GCF for those particular problems. Now I need to go back up here because there's one more word, factoring. When we factor a polynomial that contains a sum of monomials, what that means is we're going to find an equivalent expression that is a product, so that when we multiply together like we did in the prior chapter, we'll come back up with that expression. So in example 2 through 5, so there's some more problems, factor out the greatest common factor. So my greatest common factor here would be just a 5. But now if I factor out a 5, I'm going to go ahead and finish what we call factoring. You put a parenthesis because now I've got to go back and divide each one of these, and that should come out evenly. So if I divide 5 into 5x squared, that would leave me x squared. 5 divided into a plus 30 would give me a positive 6. I have just factored that binomial, because if I distribute back through, I should come back up with that expression. Let's try this one. Let's see, common factor, I've got 18 and 27. This is where your multiplication tables do come in handy. 3. I'm going to do 3. It's not the largest, but we'll see. Xy's, I'll do an x squared. So if I factor out a 3x squared, that would give me a 6x divide this into this. So I am doing what we did in the prior chapter. And 3 into 27, that would give me a plus 9. Now, anytime you factor, you need to double check and see if you factored out the most you can. If you notice 6 and 9, they still have something in common, another 3. So I could do this. Factor out a 3, divide both of those by that. Now if I multiply that right there, the 9x squared, the 9x squared, that actually is my GCF. So once you do factor, you do get the numbers smaller, so it's a little bit easier to see if there's anything else, any other numbers that they might have in common. So let me get the other sheet, because we have a few more problems to do. Number 4. Try it before you let me do it. So just pause me and do example 4 and example 5. 4 would be my largest common coefficient. X-wise, I'll do x cubed. So divide that into that. I'd have 4x squared. 4 into negative 12 is a negative 3. X cubed, if you put x cubed under here, notice you just have an x left. And if I divide this by 4x cubed, I'll have a plus 1. Some people leave that 1 off. You have to be able to distribute this back through to get back to your original expression. This one, I always look for my smallest numbers because that's going to give me a clue. 9 is going to be my largest number I can pull out. X-wise, I see I can factor out an x and a y. Parentheses, so divide this into this, that would give me a 3x y squared minus, looks like a y, plus 9. And if you'll notice, there's nothing else in common. So that's actually factoring out what's called a common monomial. The next part, these particular problems that we're doing right now will help us in the remaining sections in this particular chapter. Now it says greatest common binomial. Remember, binomial means 2. So they're a little bit easier to see. Notice I've got an x plus 3 and an x plus 3. That is a common binomial to this term and to this term. So when I factor out, I use parentheses, so I've got x plus 3, and in my next parentheses, I write down what I have left over once I factor these out. So if I factor that out of this term, I have an x squared. Factored out of that term, I have a plus 5. So that's it. Now I've got this term and I've got this term. What they have in common is the y plus 1. So I factor out a y plus 1. What I have as leftovers is x minus 2. So that's that one. Now factor by grouping. Grouping means, if you'll notice, I've got 1, 2, 3, 4 terms in each one of these. So when you do grouping, you look just at 2 terms at a time. So I look at my front 2 and my back 2. If you can't make braces like that, then do this. But I want that sign to stay with that second group. So out of this group, just focus on this, nothing else. Just pull out a common monomial. So in this case, I'd be factoring out an x squared. And if I factor out an x squared, that would leave me an x plus 4. Whatever sign leads that second group is what goes here. So I'm going to be factoring out a plus something. So if I look at the second group, let me use my other hand, I see I can factor out a 3. And if I factor out a 3, divide both of these by 3, I'm ending up with x plus 4. Now, check it out. I have got that one and that one. So now I factor out the common binomial. And write in parentheses what I have left once I pull that one out and that one out. This one, first group, I see I've got an x in common. I said that whatever sign leads off that second group is a sign that's going to be factored out. So I'm going to be factoring out a negative, looks like a 4. Be careful here, since I'm factoring out a negative 4, what's going to happen in here is these signs are going to change. So a negative 4y divided by negative 4 gives me a positive y. A negative 20 divided by negative 4 gives me a plus 5. So now I factor out a common binomial. Whew. Y plus 5. So I'm going to take that out. So in my second parentheses, I've got an x, and I've got a minus 4. So that's it for this one. Thank you.